Welcome to Season 14 of the Regimen. Joining us today is Dr. Navindra Seeram for a fascinating discussion on medicinal plants and how they can be used for their health benefits. Hello, pharmacists and friends. Today is Tuesday, May 28th, 2024. Welcome to the Regimen, where public health pharmacists, pharmacy students, and our guests discuss the latest public health issues and solutions. Listen in to find out how we all can improve population health, health equity, and patient care through advocacy and education. My name is Liz Arnold. I'm a sixth and final year Doctor of Pharmacy student at the University of Rhode Island, working alongside Dr. Bratberg in the Rhode Island Department of Health.
Thanks, Liz. I'm Jeff Bratberg. I'm a clinical professor of pharmacy practice and clinical research at the URI College of Pharmacy and the Academic Collaborations Officer at the Rhode Island Department of Health. As a reminder to our listeners, the opinions expressed in this podcast by the hosts and guests do not represent the opinions of the United States government, the Rhode Island Department of Health, nor the University of Rhode Island.
Everyone wants to know what they can eat, drink, or take to protect or even improve their health. Today, we'll be talking about medicinal plants and health. Joining us today is Dr. Navindra Seeram, a professor and chair of the Biomedical and Pharmaceutical Sciences Department in the College of Pharmacy at the University of Rhode Island. He has co-authored over 220 research articles, 11 review articles, 18 book chapters, and holds 8 U.S. patents. He has also co-edited 3 books, is the founding editor of Clinical Pharmacognosy book series, serves as a consultant and scientific advisor of several life science companies, is on the advisory board of the American Botanical Council, and is on the editorial advisory boards of several esteemed journals. We are honored that you took the time to join the podcast. Thank you for being here today.
Thank you, Liz and Jeff, for having me on your podcast.
You're so illustrious.
Thank you.
It's great to be here. You have an illustrious bio, and you're still a nice guy, and even came early, and then I came late to the record, so you're on top of everything. But what we're curious about, what was with our guests, is was there a moment where you knew that this was the journey scientifically and academically that you wanted to be on?
Yeah, I'm going to try to make this as short as I can. So I am actually from South America, from one of the Guyanas, British Guyana, which turns out is the only English-speaking country in South America. There are 2 other Guyanas, Dutch Guyana, which is Suriname, and French Guyana. So I'm testing your geography here. British Guyana is now known as Guyana, and it's neighboring to Brazil and Venezuela. This is important because the Amazon rainforest is in Brazil and in Venezuela and also in the Guyanas. So I grew up in Guyana, did all of my undergrad studies there in chemistry. And then I migrated to Jamaica in the Caribbean, Kingston, Jamaica, where I pursued my graduate degree, my PhD degree in natural products chemistry. You could see a theme here that I'm talking about medicinal plants. And after finishing my PhD, my wife and I and our 1-year-old son, Joel Seeram, who is just a PharmD, not recently, a year ago.
Yeah.
From our URI program here.
You got it.
And my daughter, plug that, she's a P1, PharmD, also here at URI COP. She's going to be a P2. Did a postdoc at Michigan State. Worked a lot on fruits. Tart cherries, it turns out, is the leading crop in Michigan. Michigan is the largest state that produces tart cherries in the United States. And then after 3 years of postdoc, went to UCLA, where I did a 5 years of working clinical studies on medicinal plants. And then to get to the bottom here, I came to URI Kingston, Rhode Island.
That was the draw, the name?
That was a draw.
Is it that different than Jamaica?
Very much different. So I left the West Coast to come to the East Coast, Kingston, Jamaica to Kingston, Rhode Island. And here I have been for 16 plus years, heading up the botanical natural product research for the college.
I just have to say, I've talked with several of my students, and I think Liz and I have talked about this, the tart cherry juice, the sleepy time.
The sleepy girl mocktail.
Yeah.
The sleepy girl mocktail.
Yeah.
So is that a thing?
Yeah, it's a thing. And this is the problem that we have here with medicinal plants, and we'll dive into this later on, is many of them are medicinal foods or edible plants. So the problem sometimes is when you have these medicinal plants which are not edible, they could be toxic. The good thing is when you have medicinal plants which are edible, like tart cherries, and then you start to dive into, well, intuitively, we know mom and grandma says to eat your fruit and vegetables and eat your colorful fruits and vegetables and eat your grains and drink your beverages. But how do they work? Are they really beneficial for us? And that's where I think For tart cherries, we have done a lot of work in terms of gout and inflammation.
Oh, yeah.
And there's been tons of studies since then. But does it work for the mocktails? I don't know. Maybe for a cocktail? I don't know either.
Maybe it's just having the mocktail is the health benefits of not consuming alcohol before bed. So
That too.
Good for sleep. We know that.
Yeah, so actually going along the lines with the tart cherry juice sleepy girl mocktail, I work in an independent pharmacy and we have a pretty large selection of natural products, and I see people coming in all ages for all types of things, and even close friends and family have told me the things they're trying, some of which artichoke leaf extract, milk thistle, and pumpkin seed oil. So can you explain the difference between vitamins, herbals, homeopathy, and medications, and how pharmacognosy relates?
Yeah. If you're listening to this, and I hope you are, pharmacognosy should roll off your tongue. Pharmacognosy, it's the mother or the father, if you will, of pharmacy. This is where, back in the day, humans who co-evolved with plants figured out ways to use natural resources and sources for their medicines, preventive, therapeutic, whatever it is. The WHO actually estimates that over 80% of the world's population, people in developing countries, in underdeveloped countries, they still do use medicines from plants as their first line of defense against diseases. Now, pharmacognosy is this very complicated cross-disciplinary research area where people are looking to discover drugs from natural sources. It doesn't only have to be plants. It could be sponges, marine sources, terrestrial sources, animals. And it involves everything from drug discovery, extraction, isolation, bioassays to history, cultivation, ethnobotany, and ethnomedicine, which I'll tell you more about in terms of traditional cultures using plants. And then we discover drugs from those plants. Good segue for later on. But vitamins, minerals, amino acids, these are all dietary supplements that people do take over the counter, by mouth, orally. Herbals or botanicals are one part of those dietary supplements that people take. And I estimate there are over 3,000 different plants which are integrated within dietary supplements that folks take. Wow. And there's sometimes multiple mixtures of different botanicals that people do take. So it's wild, wild west out there when you get to these products that people do take.
I have just one segue when you talked about, the father or mother of pharmacy or of how we use medicines, is they found, I listened to this podcast called 5 Good Things, because we all need good things in our life, and it's like 5. And one of the 5 good stories they talked about was they discovered an orangutan that chewed on some plants that the humans around where it lives do the same thing, chewed on the plants, and there's an active compound to reduce inflammation, and actually applied it, and the leaves served as a bandage to an infection on its face. And they're like, wow, maybe we don't actually know how far back these things, and they're kind of like, well, did it observe the humans do it, or is this something that orangutans always do? Unknown, but it's sort of a really interesting thing when you think about the history. So I don't know if you want to comment or if you knew about that.
Yeah, I'm also fascinated because, listen, plants have been here before us. They're probably going to be here after us. But when you think of plants which are rooted and they cannot get up and escape from all the attacks that they go through, and so they produce all these secondary metabolites, these natural products, which are serious chemical compounds. And then you fast forward and you look at animals and humans co-evolving with plants, and maybe plants chose us to cultivate them for us to eat some of their berries and to pollinate and to be colorful. And we learned somehow, and I don't know, in traditional Chinese medicine, there's no lab-based studies. It's all clinical trials. It's been happening for centuries. Ayurveda is the same thing. So somehow we figured out, don't eat that plant because the orangutan is not eating it. It's probably toxic. And we have cases of very serious, cancer drugs, anti-cancer drugs from plants. Or maybe we eat that plant because the animals are doing this. Birds eat it for a purpose. They're dispersing the seeds. Maybe we eat it, we get the same benefit. So this very complicated, I think, I don't know how to describe it, but how humans and animals and plants co-evolved over centuries. And we're still learning so much from plants. Psychedelics, toxins, world-saving medications. Aspirin is a good example, Jeff. Orangutans were chewing on that plant, as you said. Well, in medieval England, they would take the bark of the willow and they would chew on it, and pain and inflammation would go away, and there was salicylic acid, which is then derivatized to become aspirin, a drug that's been around for 100 years. So good examples of plants providing humans with compounds for modern pharmacy, for drug-like compounds like we know them right now.
One, I think, and this might be coming up later, but we always hear the dose is the poison, right? And so you mentioned anti-cancer compounds. Do you want to talk? I'm curious. You mentioned aspirin and willow bark, but how people discovered some of these very, very prevalent anti-cancer compounds from plants. You want to talk a little more about that?
Yeah. Everything is a poison. It depends on the dose. So everything is going to be toxic, and there's some like homeopathy where you're like, well, a little bit of toxins is probably going to be good for you because what doesn't kill you makes you stronger.
So or lets you live to see another day.
Yes.
Right?
So apart from edible plants, we can eat a lot of foods. I doubt anyone is ever going to overdose on anything that's edible. It's been in our diet for so long. But again, to get back to the question that you asked, in terms of toxic plants or plants which have psychoactive compounds in them, how did humans figure out how to optimize? It's because of pharmacognosy. Mm-hmm. And there is good examples of a drug that's known as artemisinin. This is an anti-malarial drug that was discovered from the Chinese wormwood Qinghaoshu. And when the scientist Yu Tu, who won the Nobel Prize a couple of years ago, maybe more than a couple of years ago, for that discovery, when she was charged by the Emperor of China to say, look, I need a cure for malaria. What do you guys have? So she went back into the TCM books, traditional Chinese books, looked at all of the herbals they were using, found the Chinese wormwood as one of them, isolated and identified artemisinin from Qinghaoshu, which is the Chinese sweet wormwood. So there you go, a good example of people who have been traditionally using plants for a certain purpose or not. And good examples of people taking foods like yucca or cassava, which has cyanide glycosides in it, but they figured out in the Caribbean and Africa how to boil it first, throw away the water, thereby getting rid of the toxic compounds and then consuming it. So is it trial by error? Maybe people tried it, died, and we learned, or animals didn't eat it, or animals died, or animals were using it. I don't know. Your guess is as good as mine, but one thing you can take to the bank, medicinal plants are medicinal, and medicinal foods are medicinal beyond the basic nutrition that they can give us. There are additional benefits that the epi data suggests and supports. You are what you eat. Food is your medicine. And if you're consuming a plant-based diet that's colorful, including colorful fruits and vegetables, and their derived products like dark chocolate and beverages like coffee and red wine in moderation and tea, then you can actually delay and or prevent the onset of many chronic severe types of certain types of cancers, neurodegenerative diseases, metabolic syndrome, etc., etc., etc.
One more follow-up. It's interesting you talk about plant-based, and I find it's so perfectly timed that we have a plant sale here from our medicinal garden, and I'm just smelling all the delicious basil that I picked up for my family, and the tomatoes that are super colorful, and all these other things. You talk about this colorful. Is that there's a thought that as in pretty recent times we've moved to a less colorful, less vegetable-based diet, less colorful thing, all processed foods and things, that processing somehow takes out those nutrients that may have medicinal qualities and may delay these things. And so there's this idea of, are we not taking in, and I'm being very purposely vague here, but we don't have those natural anti-inflammatory things. And now we go, so sort of shifted to be we use very concentrated derived anti-inflammatories like ibuprofen or aspirin. And we're moving away from sort of a balance between, I really like how you talk about the balance of environment and food, and you are what you eat. What do you think about that? My partner is very obsessed with turmeric, right? And turmeric is yellow, it's tasty, it's spicy, and this idea of where they fit in. And what do you think about that? How diets have changed away from it, and you're advocating to go back towards it.
I think a lot about it. Yeah. 50,000 years ago, ancient man, and this is facts, the ancient man would hardly have meat when they could hunt. They were walking a lot. So there's a lot of exercise involved. They were eating a lot of plant foods, roots, tubers, flowers, herbs. I like that you bring up herbs like basil, because spices,
Right.
people don't think of them as being medicinal, but when you open up your spice cabinet, there's a lot of good spices like turmeric. 50,000 years ago, that's what we were doing. Now, because of industry and the way that we refined and processed plant-based food, we removed all of the good plant phytonutrients, the antioxidants from foods. We refined sugar, we refined pasta, we added dairy, we added a lot of dairy, we added alcohol and tobacco, and we stopped eating that 5 to 7 servings of fruits and vegetables, colorful, that we were doing 50,000 years ago. So yes, maybe our DNA, our genes are expecting us, because we have evolved, co-evolved with medicinal plants and medicinal foods to really eat them, and we stopped doing that. So we switched our diets, and we're starting to, see different types of diseases. Now, I would like to segue in, but there is a reason that we see color, and according to my understanding, birds and humans are the only creatures who can distinguish trichromatic. So birds can actually see a colorful berry against a dark green background. Humans can see the same. And so plants, when they produce colorful leaves or fruits or flowers, it's for a purpose. Now, I did a very interesting research. You can actually Google it and look up birds are bird brain and birds from Block Island, in collaboration with Scott McWilliams next door from Natural Resources. When I just came to URI from UCLA, he was wanting to figure out, he and his group, as to what happens on Block Island when birds are flying, they're migrating. So they come up north, bounce off of Rhode Island. They stop on Block Island. And at this time of the year, which is fall, there's not many insects for them to eat anymore. So they start to eat 2 to 3 times of their body weight in berries. And though they collected berries, and we showed that the birds were selecting berries which were more colorful, the ones which had the most polyphenols or antioxidants, which are anthocyanins, just like we eat blueberries and strawberries. And it was interesting that we kind of postulated, and has been shown since, that birds are super athletes, and as they're flying thousands of miles and they stopped and they ate those berries, they were getting anti-inflammatory compounds from those berries, like in tart cherries, that were then potentially maybe preventing oxidative stress as they went off to land where they had to. So very interesting that we can see color, and you should see color on your plate. So you should look at that, and that color is also white, chives and garlic and onion, but it can also be green and purple and red and all the other colors of the rainbow, if you will, should be on your plate.
I'm feeling better about my lunch now, but there is meat and cheese, so I'm just gonna, baby steps, I guess.
So in season 12 of The Regimen, Tony and Dr. Ratberg interviewed recently retired Professor Ann Hume about dietary supplements. So what insight would you like to share from a scientist's perspective?
Yeah, I listened to Dr. Hume. I'm a big fan of hers. I love her humor. I love the F-bombs.
Yes, she never fails to make us laugh.
I think she did a great job as to kind of highlighting some of the issues we have with dietary supplements, which include adulteration, efficacy, and all of the above. And dietary supplements are meant to supplement the diet, not replace the diet, right? So,
right. I think people misinterpret that.
I think they misinterpret that. So if you're not getting your vitamins and minerals from your normal diet, which hopefully you should, and you're not eating too many, what do you have for lunch?
I have watermelon. Something else.
Well,
cherries. I have cherries
today.
You had
cherries today. But maybe there are folks who are only eating potato fries and ketchup and maybe a burger. Mm-hmm. And so there's no color in their diet. And maybe they're not getting some of the phytonutrients they should get, and vitamins and minerals and amino acids. So maybe in that case, they should supplement with some sort of a dietary supplement. A good example is fish oil. I believe in the science of fish oil, and maybe I'm not eating my salmon or tuna or those fatty fish 3 times a week to get enough omega-3 fatty acids in my diet. So I could supplement with a fish oil capsule, and I know it's coming from a good source. So there is good, bad, and the ugly for dietary supplements. But again, they're meant to supplement. So your partner should eat her turmeric as a spice if she can, instead of taking 2 grams of turmeric in a capsule, because then the dose is off, and we're not intended or meant to be eating turmeric 2 grams. Right, like that.
So these products are best consumed in their natural state, if that's correct?
If you can integrate these products, medicinal foods, in your diet, that's the way to go. However, I'm not negating maybe there are times when a dietary supplement may be advisable for someone who is not getting it in their diet. And listen, let's be frank, not everyone all over the world are going to have access to healthy foods like some of us do in some parts of the world. So does a dietary supplement like calcium have a role, or vitamin D or vitamin E or vitamin C? Yes. But again, can you integrate them in your diet? That's the way to go. If you can't, dietary supplements have a role to play. And I can get into more, hopefully later on, as to, in terms of research into medicinal plants, how dietary supplements can be exploited or used as a tool to leverage the science to really explore. And maybe let me say it right now. If I want to investigate if cranberry juice is good for urinary tract infection for prevention,
That's another episode.
Yes.
that's another episode coming up from you guys. But now I want to design a human clinical trial, double-blind, placebo-controlled, and it's very hard to have a placebo for cranberry juice.
Yeah.
Maybe there is a role that a dietary supplement that's in a capsule having the bioactive constituents from the cranberry fruit that I can then deliver. Quantity I know, over and over, it's consistent, it's standardized. Now I can understand without having the juice of the cranberry juice with the added sugar, complicating my
Refined sugar, of course. Yeah.
So there is a role for dietary supplements, I think, for sure, but it has to be carefully thought out in terms of research and also in education for patients.
And what about teas? Like, I'm a big tea drinker, like multiple cups of tea a day.
Yeah, tea second to water is the most consumed beverage in the world. And it's a lot of Chinese drink tea, a lot of Indians drink tea, and they drink tea a lot. Now, the tea, this is a good example of another plant which has traditionally been consumed as a hot water on the tea leaves that's allowed to steep, and then you extract those natural plant antioxidants, those polyphenols, into that liquid, and you drink that. Now, am I going to have a tea extract that has 2 grams or 3 grams of the tea extract? That's not how it was meant to be consumed. And then we go further and we say, hey, there's a compound called EGCG, which is present in tea. Now I want a gram of EGCG in a capsule. So now we've gone to the reductionist view of using that medicinal plant as a beverage, as a food, into a dietary supplement or a capsule that has other constituents with it, or one constituent from the plant that's not the way it was meant to be consumed.
When it sounds, I mean, the other thing is it's complex, right? So there are all these studies about coffee having benefits to people, and it's because I'm, I have a salary where I can have coffee anytime, all day long, and am I brewing my own coffee? And it's I've had students who've been very obsessed with how 193 degrees and how much time and cold, like it's become this coffee culture. Are we just chasing what I perceive and is accurately called a psychoactive substance, caffeine, or is it everything else? Like diabetes, we see lower rates of diabetes when we look at stratifying people about how much coffee they have, right? It's not caffeine capsules that you're taking. You're drinking, this bean.
Exactly. You're drinking everything from the bean. The coffee is actually a coffee berry.
Oh, yeah.
So it's a berry just like other berries, and the beans are either roasted, and with the way we love them, with caffeine in it for sure, but there are many other compounds, just like in tea leaves, within that beverage as you're drinking it. So again, with the whole food matrix, where the whole is greater than the sum of its parts, is the way that we have traditionally been consuming and getting the benefits from the foods, versus now we're trying to have caffeine alone, or trying to go after some sort of a constituent, or maybe a class of constituents. That's not the way it's meant to be. So, good point. Many other examples. Red wine, in moderation, contains this compound called resveratrol, which is in very tiny quantities in red wine, and is believed to impart some of the health benefits of red wine, like seen in the French paradox, which is where French eat a lot of steaks, just like we do here in the United States, but they drink a lot of red wine. And some of the lower incidences of heart disease and cardiovascular events are thought to be because of red wine consumption and this resveratrol compound in it. But then again, red wine or red grape, or grapes for that matter, have tons of compounds in them. And so are we going to want to drink resveratrol alone, 1 gram, 2 grams? Then bets are all off, because now we have reduced that medicinal plant into trying to taking like a drug-like approach to it, and they're not meant to be drug-like many times. They're more preventive and health promoting than therapeutic.
Well, and also the French work less, they retire early, they have greater family connections. Like there are all these other social concerns. They have national health care. They have, so there's all these other things. Like we can talk about just coffee or just red wine, but it's really their whole diet. And even in modern times, anybody who's ever, last year I was in Europe with my family and we're like, this is the best tasting strawberry ever. And they just have different regulations. It's built on small farmers, all these other very, very complex things that you're right. You isolate these compounds as a chemist, but you're like, which compound and what ratio? And every time you add a compound, I'm sure it just gets very, very complex.
Good point, Jeff. Sometimes we go chasing after that one active ingredient and then we lose the biological activity when we start reducing or removing one compound from that whole plant mix. You're right. Lifestyle plays a lifestyle, diet, exercise for sure. It's very complicated, but we're complicated organisms. We're creatures with our microbiota, our liver enzymes, the stuff that we eat, our health, our mental health, yoga practices, medicines, herbal medicines for sure, but there's a lot of meditation that goes into those type of traditional systems of medicine. So listen, at the end of the day, there's not much we can do, but choosing what we eat is one of the things that we could do.
Because I just want our listeners to know that human 50,000 years ago eating all the colorful fruit and the berries, they still only lived till like 35. So, so there is advantages to so-called modern medicine. We have antibiotics. We have the other, which again are primarily derived from natural, from other bacteria and things.
Yeah, go to your dentist. Make sure you do your regular checkups and stuff. Yeah, ancient man didn't have the advantages that we do right now, but we're living longer, so we're seeing different types of diseases. We're seeing Alzheimer's disease and other neurodegenerative diseases that possibly maybe these plant-based foods can delay the onset of you potentially getting these type of diseases. So interesting.
This is making me really want to go down to the plant sale.
Oh yeah.
So going back to how you studied in Guyana and Jamaica, can you talk about how medicinal plants were used there and being able to study in the rainforest?
Yes. Thank you, Liz. That's a great question. You see, sometimes, sometimes, I don't know, we choose our careers or sometimes our careers choose us. I'll be very philosophical here. And sometimes I didn't know I was going to be where I am today. I just knew at that time, growing up in a very poor country, Guyana, that my calling, if you will, was to kind of understand when mom says, take turmeric because it's going to be good for you, or you have a tummy ache, drink this, or toothache, do this, that there's something in here that I need to kind of understand. And so my pathway from Guyana to Jamaica, where I pursued my graduate degree and trying to understand in plants. But fortunately for me, when I was in Jamaica doing my PhD, I was actually working with forensic sciences in Jamaica, just like the CSI movies. Well, maybe not just like the CSI movies, but we were at one point there's a lot of drug cases, cocaine, trying to understand when drug mules who were transporting cocaine and these packages break in their stomach, that what happens to the toxicity and where the compounds are getting to the different organs and stuff. And it kind of piqued my interest because from there, when I came to Michigan State working with torch-cherries, as I said, and then to UCLA, trying to understand when you eat these plants, or what's getting to the tissues, actually what's present in the plant. Right. And that's where the rubber meets the road, because is it really what's happening in vitro in all of our cell-based, enzyme-based assays, what's happening in vivo? No. Dr. Hume talked about the pH, chopping up Prevagen and proteins, here we are. These compounds are now getting into our stomach, really acidic, being chopped up, and our liver's job is to really take these compounds, and they're xenobiotics, they're foreign substances. They want to, let's excrete them, phase 1, phase 2, and we're going to pass them out. And then our gut microbiota is here trying to do work on the stuff themselves too. So it's interesting for us to kind of understand, is what in the torch-cherries or in tea or in broccoli or in pumpkin seed oil, is that what's really getting in our body and circulating? And so that's where I think my fascination for what I've been doing in terms of the bioavailability, the absorption, the metabolism of these compounds. Can they get through the blood-brain barrier? Can resveratrol get through the blood-brain barrier? So kind of trying to understand that. I don't know if I answered your question there.
Yeah, you did.
Okay.
That's very interesting.
Okay.
Yeah, I think it's, everybody reads a mouse study, right? And they go, well, here's the next cure, right? And, if all three of us are owners of that company, we're very happy for the more investment and the media attention. But many, many of these drug candidates don't end up doing anything. And I guess I have another random, question is like, is AI something that, I know that AI has been touted as the next, thing in drug development. Is AI able to help in pharmacognosy in any way?
I think so. By the way, I just watched Atlas last night on Netflix with my wife, starring Jennifer Lopez. If you haven't seen it, it just got released on Netflix. So it's very interesting how AI, back when you're watching Terminator and so on back in the day. But on a serious, on all seriousness with AI, imagine having a tool that could screen hundreds of thousands of fractions from hundreds of thousands of plants in a very smart way that doesn't require us to be going through cells and animals, and kind of give us a hit or a lead to kind of really save us tens of years or 20s of years and a lot of time. So I think AI for sure, like in every discipline, is going to impact pharmacognosy. We don't know much yet, but let's do this maybe 5 years from now, Dr. Bradberg,
sure.
And we'll know much more.
Here.
Much more at that time.
Well, it's funny. My phone got run over by an SUV this weekend, and so speaking of mental health, it's really great. We'll do a whole podcast on how put your phone down for 2 days and you see the world, you see all the colors instead of your phone. But it's funny. So I went to go get a new phone, and I actually said to the guy helping me out, I'm like, "Oh, I joked, this is why there's humans helping you because you know the system." And he's like, "Yeah, there won't be humans here in 5 to 10 years. It'll just be automatic." I'm like, "Well," Liz and I were just saying that, the AI and Google, recommended how to make a good pizza sauce to put glue in it. So I think we still need humans to screen things and assess things. And we sort of need what's in front of us. So
and that was, the movie, kind of delved into that a lot with AI and humans. And, I think I was watching the news the other day, and they're having like Apple and Dell computers now with AI built in. For students who are going to school. It's going to be like part of the programming that comes with all of our smart devices. It's going to be interesting to see what the future is like. So Liz, you're in school now. So what's gonna happen with the incoming, I don't know, behind you 10 years from now? So
I know
we're going to be integrating a lot of AI into our curriculum, I hope.
They'll write all our scripts. It'll be great. They'll just reproduce our voices, and we'll just put out podcasts every day.
I know, it's crazy. I know it's starting to get written into the syllabus for most classes.
Oh yeah.
Yeah.
All right, well, let's talk about physical things. So this is good. Get people to visit URI.
So, as the chair of the BPS program, how does the URI College of Pharmacy promote, study, and teach pharmacognosy?
Yeah. URI, listen, let me back up a little. There was a reason why I left the West Coast to come to the East Coast, and it was not because of Kingston, Rhode Island versus Kingston, Jamaica.
The winters?
The University of Rhode Island College of Pharmacy is the Mecca, if you allow me to use that word in quote unquote, is the Mecca of pharmacognosy. The Bible, if you allow me to use that word in quote unquote, on pharmacognosy was written by our first dean's dad, Heber W. Youngkin Sr. So this college is great in many, many things, like infectious diseases, Dr. Bradberg. But its pharmacognosy program is second to none on the East Coast. We are one of the only colleges, handful maybe, that still has a strong pharmacognosy program and has a medicinal garden associated with the college. Our first dean here at the Kingston campus, Heber W. Youngkin Jr., who is the son of Senior, who wrote the pharmacognosy textbook, saw that vision. And so one of the motivating factors for me to move was to come as a pharmacognosist. If you want to do pharmacognosy research and education and teaching, this was the place to go. And physicians, and they don't take pharmacognosy. They don't have a clue probably about some of the stuff that we teach our pharmacy students, because our pharmacy students, our pharmaceutical scientists on PharmDays, you're it. The buck stops at you. You are going to be the experts, and you are. You will know where to tell your patients where to go, the good, the bad, and the ugly, because we're teaching here at URI about pharmacognosy, and we're doing active research in the field. In the Department of Biomedical and Pharmaceutical Sciences, there's a bunch of faculty who are working in this area. So this is a place to be. I am excited to be here. I am so excited to see where we're going to go in the future, building on the history that we've had and standing on the shoulders of giants like Heber W. Youngkin Jr. and Yuzuru Shimizu, who were stellar leaders in their field, and they came before us.
And unfortunately, I wasn't lucky enough to take one of your electives, but you do teach several here.
I do. Medicinal plants is one of them. And we bring our students into the garden, and so they can see what a basil plant looks like or a cranberry plant look like in terms of the pharmacognosy and understand the chemistry. It's a privilege because, again, we're only a handful of colleges that has a garden. And for our students to have that exposure is awesome.
Just an anecdote because, it's an audio medium, but we did have a toxicologist who teaches, and I actually give that lecture now on antidotes and things. And he walked through the garden, and it was just funny. He's like, and that plant is toxic, and he points to the other one, that plant is toxic, and oh yeah, I treated somebody who ate too much of that. It goes back to the doses, the poisons, and your colleague was on talking about PFAS. Angie Slitt was here, Dr. Slitt was on, so catch that episode with Dr. Scarpa. And so it's really interesting how all these things, build together, and then the PharmDs take that knowledge, and we recommend things, and folks come into our pharmacies and have these questions, and Liz and I talk all the time about what's on social media. I have to ask, what do you feel about sort of information or misinformation about medicinal plants on the internet? What's Liz is the next generation and is on social media, and so am I. And
we got to be careful of the generation that gets their news from social media. Right. But just before I get to that point, yes, our garden, if you are here, if you ever come to the Kingston campus, it's in its full glory. We have over 200 medicinal plants from all parts of the world in the garden with nice labels on them. We actually have a good website. You could check it out too. Many of them are in pots also. So like my students have never seen a sugarcane plant or a coffee plant. And we have them all here.
We have coffee plant here?
We do. So you could see them all. You could see them all go into the garden or check the pots. Aloe and agave and tons of other stuff. But to get back to your point, listen, there's a lot of stuff out there on the internet. We don't trust them. There's a lot of stuff on labels of dietary supplements that we have to question. Is what's in the bottle actually what's on the label? And so we have to be curious. We should question. Our students should question. There are good places to go. And I know you're probably going to want to ask me about that. So let me just answer it right now.
Yeah, perfect.
The National Institutes of Health has this agency called NCCIH. I'll tell you what that means in a second. Before that, NCCIH was called NCAM, National Center for Complementary and Alternative Medicine. You said alternative medicine is not medicine, so they renamed it.
It was all me.
It was all because of Dr. Bradberg. And it's now called the NCCIH, which is the National Center for Complementary and Integrative Health. That's a good website for you to go because they have topics A to Z and herbs at a glance, and you can get good, authentic information if you click on those links. And then, they have links to PubMed where you can go and get good papers if you really want to be that kind of person, delve into deeper. They have links to the Office of Dietary Supplements. So a good place for you to go to find good information on medicinal plants and on natural products which integrate botanicals in dietary supplements. But yes, you want to make sure a consumer who is out there, you're safe if you're eating a spice. You're not going to overdose on any spice because you shouldn't be drinking or eating 2 grams of anything. Your spices there in a small shaker, they're expensive. And if you're using a little bit of cinnamon or bay leaves or, basil or oregano or chives or, I'm running out nutmeg. And
you're doing pretty good. I'm like, okay, I know where all those things are.
Turmeric and black pepper and cinnamon. Those are all medicinal plants which are very concentrated, and you should integrate them in your diet for sure.
Very cool. We'll do cooking class
all
next time.
I'm thinking about now is the saffron, expensive saffron.
Oh yeah,
saffron. Yeah.
Yeah, because it's only grown in certain parts of
Yeah.
the world. Actually, we're going to have you back, because I want to talk about climate change and how that affects how we eat, and,
Yeah.
and the, shortages of plants and all these other things that
And I
increase.
think the problem with saffron is expensive also because we only use that part of the plant, the pistils. The little, we actually grow some of here at URI. They've started to grow it, and it grows very well. So it's one of the crops we're trying to grow in our greenhouses at URI to see how we can exploit. But this is a good example too, where you use a part of the plant and then the rest is being discarded. Can we investigate the leaves and the other parts of the plant to see if it has bioactive compounds? Good example, we press cranberry, get cranberry juice, but we have all that stuff, the pulp that's left over. Can we extract the pulp of the cranberry and have a dietary supplement that has the bioactives? Grapeseed extract, tons of area where we can upscale these waste products or use these byproducts to have value added. It's called valorization of natural products and food products to really, not throw it away, but use them for getting bioactive compounds.
Well, they do that with like corn. I just watched John Oliver on corn. You should watch it. It's phenomenal. But like it's by far the most grown crop. And I know that in terms of we use corn that is turned into ethanol to use for fuel. But there's I think they do research here at URI on like using cellulosic. I'm probably saying that cellulosic byproducts, like you said, from corn, and trying to derive energy-based things from that, because we're already throwing it away. It already exists. So instead of shifting food-based corn to ethanol to use some of these byproducts that exist to use for fuel, so it'd be interesting to see if there's other medicinal qualities.
Tons of others. I would like to use the word upcycling, not recycling, but you're upcycling the waste products, which are now byproducts into producing value-added products, which could be useful for us in different ways.
So you're a researcher. What's going on? What are you studying right now? We should what are you researching, and where is it going?
We're doing a lot of research on medicinal plants. My graduate students and my postdocs and my research faculty, we're always trying to be interested in what's new, what's trendy. So when I came from the West Coast to the East Coast, seems like I'm saying this over and over. I started looking at what's niche to this area.
Okay.
Everything grows in California, guys.
Right.
Everything. Nuts, berries, I don't know, whatever, you name it, except for maple syrup.
There it is.
Which is only produced in this part of the world. The plants, the sugar maple and red maple trees, they only grow in this belt that starts up in Ontario and Quebec and comes on all the way down to Florida. And so it made sense for me, if I was a professor at University of Rhode Island on the East Coast, that I should do something that's not in California. When I was there, I was working on a lot of berries and nuts and pomegranates and all of the above. So we've been doing a lot of work on maple syrup. It's a sugar. We know it is. We're trying to understand, is it different than sucrose or refined sugar? So we take sugar, which is from the sugarcane plant, or, we remove all those dark compounds. We made it refined, and like flour, process it, remove all the dark compounds and made it very refined and white. And the colorful compounds were missing. So in maple syrup, we're trying to understand, is it more than just sucrose alone? And then we branched out our research from just looking at syrup, but also sap, which is the water. It's maple water that's boiled to become syrup. And then other parts of the plant. So we're going to talk about patents soon, I think.
Yeah. Yes.
And it would be a good segue. I'll tell you more about our maple patent when we get to that point in our conversation.
Yeah. I am very interested to hear about the patents.
Yeah. So we know for sure that maple syrup is a food, and we've been consuming maple syrup for centuries, and we still will. It's expensive. It's a sugar. You want to drizzle, not guzzle. So let me caution that. But we went and we looked at what the native people, the first indigenous people, were using this plant for.
Because they were using it, and the Europeans learned from them.
Exactly.
Yeah.
This is one of the only, not the only, one of few agricultural crops that the Europeans did not bring. Yeah. It was here. So the Europeans, the colonists, learned from the natives how to get to syrup from sap. I think the natives were collecting sap, and they were allowing it to, they will drop like hot stones in it, concentrated somewhat, to get to that kind of consistency like what we have now. Probably not, but the natives were also, just like other medicinal plants, using it for different purposes. So they would take the leaves and the bark, and they were using it kind of like to bake in their breads and consuming it they used to call it for liver health, or like a liver tonic. And so we were kind of trying to understand, well, syrup aside, it's a sugar, but can we investigate the chemistry of the leaves and the bark of the different maple species? And boy, we've been doing this for, 10 plus years now. And we have published, and I say this without, very true, humbly, we have published more papers, peer-reviewed, on maple syrup, maple sap, and maple plant parts than any other group in the world. We are the world's leading research on maple phytochemistry. All right, so the patent. We were trying to use an analogy of having, and work with me here, olive oil has been consumed for centuries. Olive leaf is actually used in a capsule in many parts of the world as a dietary supplement.
For what?
I don't know. Many different things, just as you would expect.
Yeah.
And there are some leaves that people would eat, like grape leaves, but people don't eat olive leaves. Similarly, maple syrup is our olive oil. Been eating it, but people don't eat maple leaves, do they? Well, we started to look, and it seems like the Native Americans were doing it. And there's some maple teas, like in China, they would take that leaf and brew it into a beverage. So we were trying to understand.
Have you had maple tea?
I did not. I don't trust the chemistry as yet until we have human clinical
trials. That was a gotcha
trials.
question.
I know. You see, all of us researchers, too much knowledge could be a good thing and a bad thing. And so we question, people are not eating it. Is this even going to get into our food chain? And my answer is, until we have clinical trials, let's not consume this. So we went for a patent instead to look at its skin applications. Oh. So we're not going to eat it, but we can apply it topically. So the patent is actually owned by the University of Rhode Island. It's to extract compounds from maple for some cosmetic applications.
Interesting. Skincare.
And to Dr. Bradberg's question, which is a very important one, because we don't have evidence that drinking or eating maple leaves is going to be safe. Right. We're hoping to build on that data. The lowest hanging fruit was to look at topical applications. And so that's been an interesting area for beauty and personal care. Whilst we kind of investigate now, can we indeed consume maple bark like cinnamon is a bark, or maple leaves as a tea, and build that data to see, is this going to be edible? It's going to take some more time.
Yeah.
Great question, by the way. And I didn't
wasn't even prepared. Yeah, I know.
I didn't set it up for that. Yeah, look at that.
Are there any animals that eat the other parts of
the
maple?
That's a good question.
They do. There's some. Again, it's difficult to find from the books that's written, but yes, the native some animals would. So very, very interesting, but very obscure at the same time.
I'm guessing that we know more about traditional Chinese medicines and Ayurvedic. I'm probably saying that wrong, but Ayurvedic, because it's actually written. And I think the problem is that many of the indigenous folks, first peoples in North America, didn't have a written language. So, and passing down in generations, may some of these things didn't survive, right?
Fantastic. Good point. When I came here, I tried to visit with the Narragansett tribe and try to understand, are there good ethno-medicinal books like TCM and Ayurveda has? And there are none. And that's unfortunate. There's some, but the passage of the information has not been done well. And to get back to where we want to go, like if I'm living in this area, how can I understand what the natives were using? What are the plants that are present here? It's difficult to really kind of get that information. So it's like, you're guessing, well, let me just study this. And we can talk about the challenges of working in this area, but it's also who funds the research?
Yeah, that was my next question. Yeah.
Who funds the research? Now, if we can't have a patent on natural products because it's not patentable, and there is no incentive then for there to be money on patenting, something like, I don't know, garlic or green tea or red wine or pumpkin seed oil or turmeric. Then who would want to really invest in research in this area? The NCCIH did do, for sure, but it's very competitive. So then we also rely on agencies like food groups, like Ocean Spray, for example, providing some funds for in sponsored research with good contracts on conflict of interest.
And Ocean Sprays for
Cranberry
Yeah.
juice. Or, there are different bodies, agencies like the USDA. So we've been very successful in getting funding for our work on maple because it's a North American agricultural crop to study maple syrup because they want to increase American competitiveness in agriculture. But it's challenging. So there has been some support from the industry, from the maple industry, as well as the USDA for our work.
And you just submitted a big grant. I know we were
I
talking.
did 2 of them. Yes.
Where are they? Can you talk about what they're?
Yeah, to the USDA on maple. Yep. They have a special program called the ACER program. The ACER is the genus of maple, ACER. That's why if you look at the Canadian flag, you see that very point, right? The maple leaf and the Canadian flag. And yes, there was 2 grants we sent in for the market promotion and production of maple syrup.
So you're going to get funded, and then you're going to need grad students. So everyone who's listening, apply to be a postdoc in Dr. Seeram's lab. And
Yes, please come on. We're always open for business. And as you can tell, as these guys said, I'm a nice guy, and I think I am. And there's a lot of enthusiasm in my group and positive energy. And, we want to train the next generation of pharmacognosists, as well as educate our PharmDs and our pharmaceutical sciences undergrads, BSBS programs. So come on over. I hope you're all listening to the Regimen. This is a good episode, and I'm so excited and happy to be here with Liz, soon to be Dr. Liz
Less than a year.
Arnold.
got it.
Dr. Elizabeth Arnold,
Yeah.
I should say, and Dr. Jeff Bradberg, who's just an awesome guy.
Just chat.
So that concludes our episode on medicinal plants. Thank you so much for joining us today, Dr. Seeram, and sharing your expertise on this topic.
You got it.
I think we're definitely going to have you back. So for right now, you'll find out all about the Regimen, this episode, and others on our social media feed, which is at PharmD_Pub_Health. That's at Pharm like pharmacist, PHARMD as in doctor, Pub Health on Instagram. Connect with us on LinkedIn. Turn on post notifications so you never miss an episode, and smash that subscribe button on Spotify, Apple Podcasts, YouTube, Amazon Music, or wherever you listen to podcasts. Thanks so much.